Okay, so now we are streaming, and let's see how this is sort of going to work here. As big as I can. Hopefully this will all work out. So, hey, where are we? Does anyone really know? Nobody knows? Where are we?
The sample test that you passed out. Quadratic.
Good, good. Does anyone have an idea? That's the activity we did in class, yes. So that we're going to build on that. Let me syllabus. Let's also take a look at the syllabus so we all know when the next test is going to be. That'd be kind of a good idea, right? Because I don't even know when it is. So that's not good, I guess. I know it's coming up, but let's April 2nd. Okay, that's good. That's what I was thinking. Next Monday. So from the syllabus, here we are. Let's see. So we're after spring break. We're doing quadratics, and yeah, I'll have to fix up Canvas and anything else. It refers to this next exam as units or lessons 6 through 8. Because our old book, what we did is 7 used to be something else, logarithms, and they got rid of it. So it went from 6 to 8, and then they reorganized everything. So now they put 7 back in. So we're just doing 6 and 7 just on quadratics. I'll take a look at 8. How many other? Let's see. I guess we can look right here. Looks like we just jumped to 9. I don't know what happened to 8. Is there an 8?
I think so.
Let's take a look at MAT121. Yeah, I like to just focus on the learning of the content, so I've got those things down. But then when they change some of the stuff like the MAT121 on us,
There is lesson 8.
there is a lesson 8. So,
it's called solving quadratic equations.
Oh, so I guess you could kind of do it. So maybe it is 6 through 8. But I think you can probably get through most of it. Let's see. Let's take a look at what 8 is. So 8 is solving quadratic equations. They do have a few things in here that I don't have on my tests because they're not on the final. So let's just take a quick look. Solving quadratic equations. And we're really going to do all of this, but we'll do it with atom quad. So I think this is, yeah. You're welcome to use it. They use the formulas. I'm going to focus on using Atom Quad, which has the formulas built in. So what we'll do is, as we get through this stuff, we have about 2 weeks at the end before the final. As we review for the final, I'll take a fresh look at the final to see if it's been revised at all, and if it includes any of this, we can throw it in before we get there. But what we're going to focus on is having you have a real strong understanding of quadratic equations, how to find the X-Intercepts, how to find the vertical intercept, how to find the vertex, and what all that means. All these others is, 20 different ways to do it. We'll just get good at one, and then you can pick these up later. And again, when you come back to look at them, it's just doing the same thing that's being done in Atom Quad. So wherever we're at, basically here's about this time is when I start making the offers of options. Because remember, what we've done is given you many different resources to get things done. And my practice tests so far, have they been fairly consistent with what's going to be on the test? Have you found it? Okay, so I haven't lied to you. It'll continue to be that way. And the reason I know this is because the reason they are is because I take my old tests and I just make them into practice tests, and then I redo the problems for a new version of the test. And that's the same thing here. You have actually probably the combination of 2 or 3 different tests in here. When you come to take the test, it'll be the same types of problems, but fewer of them. So this just gives you lots and lots of practice. So we're going to walk through a few of these, and these are this is basic, this is the test. So these, I believe, if I counted right, you'll have 4 different types of problems that you'll have on the test. And there'll be like 4 of these particular types. So this is one of the types. We'll look at the next one. We'll look at the other one is regression, which we've actually already looked at. We'll do one of those. And then there's a couple ones with imaginary numbers. And I'll show you again how to use your graphing calculators to do imaginary numbers. And that's all we really need to know out of this unit. But today we will pick up one new concept, and that's interval increasing and interval decreasing. Okay. It's very visual, so if we draw and use Atom Quad, this should hopefully just pop out at you. But it can be a little bit confusing, so we'll try to get the confusion over by doing it a particular way. And can you guys see this okay? Should I zoom a little more? Okay, you should. And is anyone in need? I've got extra copies of the practice thing itself. Because then you don't really have to look up. You'll just look at yours. And you'll see I'm basically doing the same thing. So you can see what I'm writing. And this is not being live streamed, but it is being recorded. So then I will upload it after class because I don't want to mess with the Wi-Fi stuff that may or may not be working. So I'll just start, since I don't have that access, I'll just start having it on my disk and then I'll upload it so that you can come back and watch them later. So that's okay there. Okay, and what I will do is, again, getting the technology to upload everything, I'm going to use my calculator with Atom Quad on it. So as we work through here, we'll just kind of see this sitting over here. Quite get them all on, but we'll move it as needed. Okay. I guess I could just write on the screen, or write on the Is anyone taking summer school? You registered already? Okay, there's Math 150, and that would typically be the reason you're taking this class. You would typically take 150. I do have some students who go into 141 after this, but that's kind of the split. If you're taking 141, maybe you didn't need this depending upon your program, but I'd be happy to work with you. But we do have summer school, and then the fall schedules also, you can get registered for that. And again, I would go ahead and do that so that you can ensure the classes you want are going to be available. You don't have to pay for them until into the future sometime. You could always drop them if you change your mind or you end up moving or something. But it's good to kind of look at those things and at least get them registered. Because if we don't get 15 in a class, it ends up getting canceled. And so if you wait till like that week before classes, the one that you thought was going to be there might have been canceled, and had you and other people registered, it might have made. So that's just the thing, is the sooner you register, it gives us at the college better time for planning. Yes?
You know if I need 150 for psychology?
Yes. Psychology needs 150, 182, and usually you need some kind. The one we teach here, you would need the calculus, usually 220. There's also finite math that counts. But usually we don't teach that anymore, but ASU does. Yes.
What's the difference between 150 and 151? Or is there not?
Not really much. The credits will transfer really as the same. They're both college algebra. 150 has one extra credit, so it's a 5-credit class. So typically more time in class. 151 is 4 credits, so it's less time in class. When ASU teaches it, usually they'll do a 152, which is only 3 credits. So less time. But you're doing the same amount of work. The finals are the same for all of them. And we've debated, should we make ours 151s, because then it's 1 less credit and 1 less cost. But the teachers who teach it really say we need that extra time in class, and even with that extra time, some are not successful. So, but again, I think it is a lot of review of this class. So if you're doing well in this and doing strong, it should hopefully carry over and do well. I think 151 would be just fine.
Would it be too hard to take in summer?
No. And the other advantage you get with summer is oftentimes you're only taking 1 or maybe 2 classes at the most, so you're more focused. It's shorter time, but you're more focused. So don't let other people say, oh, you don't want to take math during summer. Maybe you do. And again, maybe you don't. Don't let someone tell you what to do, right? Because you're the one who knows best. And but the first time, I was afraid of taking summer class. The first time I did, I go, man, this is best, because I've only got 2 classes. I was able to focus on them, and I actually did much better in the summer classes than I did in the other class, because I just don't do well when I have 5 different things going on, even though I have more time to do it. It's just, give me 1 or 2 things, let me finish them, and then I'll move on to the next. So that's what the good thing of summer. Okay. So basically, all of these, as you'll see, they're set up with atom quad. We need to figure out what the coefficient or the number in front of the variables are for A, B, and C. And remember, this is all coming off of, we have to get an equation that's basically 0 equals AX squared plus BX plus C. Okay, and the numbers we're looking for, the numbers here, here, and here, we're going to put them into atom quad. And sort of almost like magic, it gives us almost all of these answers. The only ones it won't give us is interval where increasing, interval where decreasing. It sort of does give that to us, but we have to interpret it. It doesn't give it to us directly. If I knew how to program, I could make atom quad give those to us, but I don't. So we're going to learn how to take the picture we're going to draw from these, the answers atom quad does give us, and then how to answer those last 2 questions. But typically, those are the ones that people have problems with because atom quad doesn't give it to you. The other ones, as long as you know how to do atom quad, you can get all the other answers. This is the one that will kind of help us understand that you understand. Okay, so can we figure out what A, B, and C are from the equation in this form? So what do we do first? We FOIL it out. Okay, so we're going to, so these are in factored form. We're going to later learn that sometimes factored form is kind of good to work with, but when we're using atom quad, it's not, because we need it unfactored. So we take the x times the x, which gives us x squared, right? Then we take the x times the 5, which gives us what? Plus 5x. Then we take the negative 3 times the x, negative 3x, and then we take negative 3 times positive 5, negative 15. I was going to say negative 8, but I was adding instead of multiplying. Any of you guys do that? You're supposed to multiply, but you add. Sometimes those are the kind of mistakes we make. Okay. Now, can we tell A, B, and C? Almost. One more thing to do. What do we have to do? Combine like terms. So we're going to come here. The 5 and the 3 can combine. So we're going to have x squared. And this is a positive 5, a negative 3. So we subtract 5 minus 3 is positive 2. So we get a plus 2x minus 15. Okay. And so what is the value of A? So we'll write that down. What's the value of B? And what's the value of C? Good. And if you'll do this, this is kind of like the showing your work part. Now on the test, you'll see the same thing. It's not absolutely required, but why not? And if you put the wrong numbers here, I can see, oh, you forgot to put the negative 15 or something. That's why your answers are wrong. But if you do put this part, I could possibly give some partial credit because I can see where maybe the error was made, if you made an error. Okay, so these are what we're going to put into Atom Quad. What we're going to do is Atom Quad will give us a graph. That's what this area is for. Again, this is not a graded area, but it should help with the other stuff. So we'll just draw a quick sketch. Again, all of this stuff so far is just is our work. You're going to get 1 point for each of these correct answers. And again, as long as you have the A, B, and C in there correctly, you'll have the correct answers for these. So let's go ahead and turn this on. You'll center screen it. How do I get to Atom Quad?
Programs.
So go to Programs. It's right there in the middle. Push the Program button, and hopefully you have an Atom Quad. Anyone not have Atom Quad? Do you have a calculator with you? Let's get you Atom Quad. I got cables. Where did I put the cables? Uh-oh. I had them. Shoot. Oh, there's. You've got one of those. Okay, so that'll take this. And yours is perfect. And we're going to link to the Vulkan mind meld here. You're going to receive. I'm going to send you a program. It's going to be Atom Quad. Goes from here to there. It's done. Back on. There it is. So just hit program and enter. Anyone else? Everyone else got it? There's one other person I got an email from, but we'll. It is available in Canvas, the program itself, but then you've got to have the right cable to go from a computer to here, and you have to have another piece of software. So just come and we'll take care of you here. So good. If you ever leave it, I got some students that get into 150, and after this class they think they're done with it, but they'll come back and say, "Do you got that Atom Quad?" I said, "Yeah, I got it." Cost you double what it cost you the first time, right? That's okay because it didn't cost you anything. So 0 times 2 is still 0. Okay. So Atom Quad, we hit Program, Atom Quad, Enter. And then now Atom Quad's running because it says if ax squared plus bx plus c equals 0, then we can put in the values for a. Now, our equation is not technically equal to 0, but it's just equal to a variable y. So we could make it think of it as 0. But we're going to see that's important. It has to be equal to 0. In the next kind of problems we're doing, that we've got some equations that are equal to numbers. If they're not 0, we got to get it equal to 0 first. But that's the main thing. If you got your setup right, all you have to do is put in A, B, and C. So we put in 1 for A, we put in 2 for B, and we put in negative 15 for C. Okay. Hit enter. And there we go. Everyone okay with this part? Where do we go first? Options, good. Because that just makes the numbers are going to be in decimals and set up. So if you just remember to do that, go ahead and change it to decimals. Everything will look a little prettier. Then where do we go? Go to the graph, because then we could draw a picture of it, and then we have a place to label our answers. So I suggest going to graph, hit enter, and sometimes it's like this one's not a really good one because it's zoomed in too far, but you could see it does cross. So when I go over here to draw it, I'm just going to say, that didn't look real good. So I'm going to go 3 again. I'm going to take a quick look. It crossed on the negative side and crossed over here about 3 on the positive side. So I'm just going to, knowing a parabola, something like that. Okay, so I didn't draw exactly what it is, but I interpreted. I know it's going to be a U shape. Okay, and in this case, Atom Quad did not give me a very good window. Yeah, that one. So we'll just do a few of these, and then the rest, I'll give you some time because it's good for you to practice on these. Because that's all your test is going to be, is more of these type of problems. Exactly. So once you get, we'll do one of each, and then we'll see if we get any requests. And but you see, once we've got one done, we really just kind of rock through it. Then what do we do next? View the results. It's going to give us all our answers. It first gives us the X-Intercepts, so where do we put those? Well, we could put them here and here. One is at -5 and one is at 3. Does that make sense? Now we can see visually where they are. And then over here, actually on our test, it's asking for the X-Intercepts. This is a graded part. How should I write an X-Intercept? As an ordered pair, it's a point. So over here, I just wrote -5 and 3, and that's what it looks like. But notice it's telling us it's an ordered pair with the x is one of these numbers and the y is 0. So I always want to write my X-Intercepts -5, 0, and then 3, 0. So X-Intercepts are where y equals 0. And it was kind of an serendipitous, I think is the right word for this. As I was coming onto campus, one of my previous students, who's now in 150, she was tutoring someone else in I'm not sure what class, but as I walked by the science area, she said, I stopped by just to say hi because I do those kind of things, and she says, you know what, we were just wondering, we have to find a horizontal intercept. They had forgotten. And I says, well, when you find a horizontal intercept, what do you know about a horizontal intercept? She said, y is 0? I said, exactly. And I know exactly what to do. But she probably hadn't forgotten, but I guess my presence there reminded, I guess I had it written on my face, y equals 0 is a horizontal intercept. And then she could move forward. They put in 0 for y and solved it. Boom, like that. So that's, horizontal intercepts, X-intercepts always have 0 for y. So that's going to carry you the rest of the way through the math. What else do we want to know? Well, we just keep hitting enter, right? It'll give us the next thing. It gives us our y-intercept, which is an ordered pair. Now, x is 0, 0, comma, -15. 0, comma, -15. Okay, and doesn't that make sense? That's where the -15 is. That's where it's coming from? It really is. It's the C. Because if you put in 0 for x's, everything goes away except for the -15. So that one you could have spotted, but what I'd like you to do as Atom Quad gives you the answers, kind of look back at what you've drawn and say, oh, that makes sense. If it doesn't make sense, try to spend that extra time so that it does make sense. Okay. X-intercepts really don't make a lot of sense because it's so complicated how they find them for the most part, but y-intercepts are pretty clear. And then we're going to hit enter again, right? And that gives us the vertex. And what is this? It's an x-coordinate and a y-coordinate. So since the vertex is a point, we want to put it in as an ordered pair, x, comma, y. So -1, comma, -16. And that goes right here. -16. And if you want to on the graph, it's right here, -1, comma, -16. Now my drawing is not real accurate, but it sort of makes sense. Okay, so this is down to -16, and it happened at about -1. So if I had a little bit more accurate drawing, it would, I could find it too. So far so good. But this is going to be an important part of the picture, okay? Because this is going to help us also understand interval we're increasing, interval we're decreasing, okay? So if we've got this part so far, we're good. Then it asks for the equation of the line of symmetry. I can hit enter for that, and it tells me the line of symmetry. X, good, x equals -1. Where did that -1 come from? that too, but it also came from this. It's the x-coordinate of the vertex, which again, I'll put that down. Using the formulas, yeah, negative b over 2a. So we could have calculated this on our own, right? And what is the axis of symmetry? I'm going to draw it in here. It's the line that goes, it's the vertical line that goes through the vertex, right through that point. So a vertical line always has an equation, x equals that value. Okay, so that's what the line of symmetry is. Got that?
So is that the equation? So I didn't need to put a whole equation in Canvas?
Well,
And the homework?
the equation, right, is just x equals negative 1. That's all there is to it, because it's a vertical line. Had it been a slanted line, then we get into y equals mx plus b. But a vertical line is just x equals a number. Boom, that's it. The problem is we get so used to looking at x equals a number like this as if it's an answer, as it's a single point. But it's multiple points with multiple y values, but the x is always going to be negative 1. But it is a little hard on the brain because the brain's saying that's just a single answer. It's not really an equation. Y equals mx plus b we can see as a line because it's got the two variables. But when we have a single, x equals this or y equals this, it's hard for us to see that those also are lines, very special quality lines. Okay, so this is an x equals is always a vertical line. The key part is we don't need atom quad anymore because it really doesn't help us with the rest of the questions we want. We want to know the interval we're increasing and the interval we're decreasing. Now let me help you out here. In math, whenever we're talking about intervals, we're asking for the x interval. So we're looking for the x values where the y values are increasing. Okay, so interval is x values where y is increasing, or the x values where the y is decreasing. Okay, so there's, and I've worked with multiple ways to try to explain this, and it sometimes works good the first time, but not always. So, okay, so we come to this line of symmetry. What do you notice is happening to the left of this line? What kind of x values are there to the left of this line of symmetry? Negative, but less than negative 1. Good. So they're all going to be negative. So, but what I'm going to do is I'm going to write here on this side, x is less than negative 1. Okay. So would you agree with that? Because this line is where x equals negative 1. So if you go to the left of that, every value to the left of that is going to be less than negative 1. Okay. So I haven't actually started answering the question yet, but if you'll write these down, this is actually going to be one of my answers. And then what you're going to do is you're going to figure out which one it's the answer to. But so I'm going to write the answers first. If I go to the right of this line of symmetry, I got too much junk in here. If I go to the right, what are the x values to the right of negative 1?
X is greater than negative 1?
They are greater than. A lot of them are positive. There's still some negatives. There's a 0. But what we know is the relationship to negative 1 is these are where x values, and I'll write it over here, are greater than negative 1. Okay? And this will always hold true. So look at your line of symmetry. To the left, x values are less than that number. To the right, they are greater than. And what I'm going to tell you is these are your two answers. What we do now is we now look at the graph. Which one of these sides has increasing y values? Is it this side? No, these are coming down. How about this side? That's the increasing side. So the answer here, x greater than negative 1, goes right there. Okay. And you'll see when they open up, when a parabola opens downward, all that happens is these answers change places because you're looking. So this is, I'll label it, this is the increasing side. And do I have an answer key for this? I don't. Do? I do? I guess I do. See, I didn't know. So it's in Canvas. Search around a little bit, but it should be in the review section.
It's right after when you print this one.
Okay.
Next to it.
Perfect. I'm good. I'm better than I think I am some days. I go. So sometimes that's why I just copy things. Like sometimes I get things done right, and then I just leave them alone, and I just copy them forward, and I forget what I've done. But yeah, this should be in there, and I think I kind of, show you how to do this. So the decreasing side, right? This is going down. This is the decreasing. I'll just shorten it. So the x less than -1, that goes here. Okay. And that's all there is to it. I'll let you know what the type of mistakes I see. What I see is that people, since they're talking about increasing, decreasing, which is a y value, they'll put, instead of the x coordinate, they'll put the y coordinate here. But that's, and I can understand the confusion. But remember, in math, when we ask for an interval, we're asking what's the x value that makes a y value do this or that. Okay. Always when they're asking for intervals, they're asking for x values.
So symmetry, the axis of symmetry is where the intervals of increasing and decreasing is derived from them.
Yeah, exactly. It's a place it changes.
Up or down.
Yes, yes.
You said you can write it like that, or it
Oh.
can be -1, apostrophe infinity with parentheses.
Yeah, since x is greater than, you could also, so the other thing you could do here, get kind of messy, we'll try it again, but
Either answer what you're right.
yeah, so we're going from -1 to positive infinity, or from negative infinity to -1. So we could use interval notation as well. Yeah, whichever you prefer. And actually, I started using interval notation in some ways. It's kind of it's a little easier to take a look at when you're working through it sometimes than these. Sometimes, at least for me, these symbols are confusing. They just never really clicked with me, and I think that's the problem with a lot of, But then that's why I kind of like the interval notation. I can see, it's a little bit clearer. I'm going from -1 to infinity, negative infinity to -1, so that's, directions are a little easier. How's that?
So what do you use bracket?
The bracket is when they're included. The reason I didn't use a bracket on these ones, and the reason you'll never use a bracket on these, is because at the place where it's equal, this x equals -1, that point, actually we had this discussion of that's in the 150 comes up, that point actually is neither increasing nor decreasing. It's sort of the place where it stops decreasing, and it's the place where it comes up, but you need to go from one to the other. So that point itself is sort of, the vertex is not kind of included in either interval. That's why. So we're excluding the vertex itself. Very good question, though. Okay. If you did put a bracket, I'd still give it to you, but it's in the future, yeah, you want to, for precision, we don't include that vertex. So it's kind of like a little hole down anyway. So, and again, that's all you're going to do for all of these. Again, this is just another example, so we'll, FOIL it out. 3 is another example to FOIL it out. And the reason I did these, I didn't used to have these, but they have you start doing some factoring in some of the homework, which again, if you complete this, I'll take this as the homework for 6, 7, and 8, because it should help you do well on the test. And again, if you do well on the test, I say you must have done enough homework, so I don't worry about it. I think it's still helpful to go in there and do some of it, and especially some of the factoring part. But again, we don't directly test you on it, but if you get good at it, it does make doing some of the math easier. But it's also the same thing as if you're frustrated with it, it really is not going to hinder you if you're not good at it. So I'd rather you not get too frustrated working on it because you feel like you have to do it, because we can have workarounds. But if you get good at it, it will be helpful, especially if you're going on into calculus. So psychology people, if you want to play with it a bit, that's good. Okay, so far so good? Okay, so this page, same type of thing, FOIL them out, put the A, B's, and C's, and kind of go through the same process. And then we get to this side, and these ones we don't need to FOIL out, do we? Okay, and let me see. Oh shoot, these are all. I want to, yeah. Let me do this. Let me take a little bit of liberty here on number 5. We're going to work 5 together, but I'm going to change it. I'm going to put a negative in front of the x squared. So I'm going to work it this way just because I want you to see an example of when it, because that makes it open downward. And basically the only thing it's going to change is where the interval of increasing and decreasing are. So I wanted to kind of give you an example with that one. There might be one further down the road. This factoring we'll also be able to do. I'll show you how to do it. It won't be on the tip. How about if I leave these on as extra credit? That's what I think I did. These will be on, so if you can factor, it's going to be an extra credit thing. I don't remember. Not too many. You know, it's less than this. I think it's about 4 of these type, 4 or 5 of the other kind. Let's see, 4, 4, 8. It's like 15. I rarely have more than 15. Certainly no more than 20. I try to make it, since we go from 1 to 240, so that's an hour and 40 minutes. I try to make it that, you know, even if you stretched it out, you could do it within an hour so that you have plenty of time. So that most of you are going to maybe get done in 30, you know, if you study well, you know, maybe it's going to be 30 minutes and you're done, maybe an hour. But you'll have plenty of time. That's the goal, is not to rush you. Okay, so we're going to do this one and just put in a negative. So this will be different than probably the answer sheet that I've got, but I'm just highlighting, I've changed it a little bit. Okay, I'll show you how to do these. From the answers for these, we'll be able to factor this. I think even with that negative, we should still be able to do this. I might change it. Anyway, we'll figure it out. Sometimes you change a little thing and it changes everything, but we'll see. Okay, so what is the value of A? -1, because I changed that to a negative, okay? What's the value for B? It's also -1. Yeah, the invisible 1. And the value for C? 12. Okay, so we put in our A, B, and C. Then we're going to go to atom quad. And since we're still inside running atom quad, well, we're still stuck in here, right? So we hit enter till we get back to the menu. And then how can we start a new problem from within atom quad? Number 6 is a restart. And that way we don't have to change the options again. So it comes back to the very beginning. We put in our value for A, -1. And remember to use the right negative. The negative, not the subtraction. Right? So just to highlight, we're using this as the negative number. This is a subtraction key. And if you use it, I believe it gives you a syntax error and blows everything up. But it fixes itself pretty quick. Enter, -1, enter, 12. So far, so good? Okay. And just to highlight, if you ever want to double check, since it's a test, a lot of times, view formula. So if you go to number 1, you hit enter, it gives you the quadratic formula, just to show you what's there. But more importantly, it tells us what we put in. So you might want to double check, did I really put the right things in? That's a lot of times what I have to do. Okay, slows you down, make sure you got it right. Then what do? We don't have to go to 5, we just go to graph directly, because we already did 5 and we're still inside the program. So we go to graph, and again, it doesn't give us a really good one because it's, but we can see it's U-shaped going downwards. So I'm going to just draw, I don't know, something like that. Is that about what you saw? You know, again, this is just your kind of your area to have your scratch. I'll do it one more time. And I think the vertex is just a little bit to the left is what I see. So that's kind of what you want. And my vertex I've drawn here is a little bit to the left. Okay. And again, this is just sort of so we have a picture to work with. We then next go to view the results. Number 2, we hit enter. We start seeing all our results. So we've got an intersection at -4.
The letters.
What's that?
How do you get the letters?
What letters?
The alphabet is not working.
You still in Adam Quad?
Yeah, I didn't even get the Adam one, get the X and I started to enter the numbers. But when you go to the alphabet, put the X in, X2, this, that, second power, all that. I can't get the X.
No, you don't want to put X's in. You just want to
Right,
put
but
the
you do want
ABC.
The number, this supposed to go in, right?
ABC.
Right.
So, but you have to be running Adam Quad. Oh, I see. So, yeah, for A, you just want to put the number. It's in clear. Now, program. So the A, you just want to put in -1. Not that one. This thing, yeah. Otherwise you just syntax it.
Did you get option 2?
Actually, she's just still putting it, so that you're going to have to pull up the program again, because when you get clear, it jumps out. Program. So it's just a key part, but once you get used to it, it's there. And again, so we're putting in X-Intercepts, how about -4, and 3, So far, so good? Okay. We'll hit enter again. It tells us our y-intercept. Now, it doesn't put the comma in, probably because of formatting issues, but we'll put that in. It's 0, 12. And were you surprised about the 12? Hopefully not, because that's what was on the end. Okay? That's exactly where it came from. How about the vertex? So we'll hit enter. And it gives us the vertex, -0.5, 12.25. Vertex. -0.5 and 12.25. At this point, before I go any further, do you know what the equation of the line of symmetry is going to be?
-0.5.
X equals -0.5. Good. It's coming right from this value here. Okay? And again, I'll hit enter just to x equals -0.5 or 0.5. Okay. And do write it as an equation because it's asking for an equation. I've got people that just write -0.5. And I know what you're trying to say, but there is the x equals over here. It's just the formatting. Okay, so this all goes together. Okay, so let's draw that. Notice the axis of symmetry is a little bit to the left, but not much, right? So here's our line of symmetry at x equals -0.5. This is the vertex at -0.5, comma 12.25. Okay. So we've labeled those points, and hopefully it makes sense to us. And then again, what we want to focus on, if I go to the left of the line of symmetry, what are the x values? How do I represent this interval? X is less than, don't think about increasing, decreasing just yet. This is the key. This is where I messed up, is don't think about increasing, decreasing until we've got these down. Now, you might be able to do it just fine. If it works for you, great. And I've got students who do it the other way, but I find most of us that mess up is because we're trying to think about increasing and decreasing at the same time we're doing this. X is less than -0.5 simply because it's to the left of that. If I go to the right, X will be greater than -0.5. I'm hoping when I get students that will do this, they will consistently tie it to the line of symmetry, which is what you need to do. Otherwise, I start seeing them using the Y or something. Now we come along. These are our answers. We just have to figure which one goes where. Let's starting from here, is this increasing or decreasing? It's increasing. So here's the increasing part. So this is the answer to the increasing, x less than negative 0.5. Again, you can also use interval notation, so negative infinity to negative 0.5. And actually, when I got using it, I sort of liked it better than the inequalities. Over here, it would have been negative 0.5 to positive infinity. And this, again, as you see from here, on this side, it is decreasing. So I draw the picture, I see it visually. This helps your mind, because your mind will memorize answers for tests and fill in blanks, but your mind really, it deals in a language, it thinks fastest in its language of thought. And language of thought actually does better with pictures, with images. That's what we are really good at doing, processing images. So if we give it an image, we're making our brain happier and we're learning it deeper. And we're speaking the language of our brain, which is not English or Spanish or any other higher level language we've come up with. The language of thought is just like fast and it's very visual. It really is. So the decreasing side is x is greater than negative 0.5. And again, just be careful, because on the test, and again, you don't have to have both of these, one or the other will do, and just kind of figure which one works best for you and sort of stick to that one, whichever your preference is. And again, if you find that as you work through a few of these, if you find a better way that works better for the way you see it, that's fine. But I just found that if you'll concentrate just on one part, finding the interval first, and then matching which interval is increasing, which interval is decreasing, you'll have greater success. And then eventually you'll probably get where you could just look at it and it's just there. And some of you might have done this previously, so you might have this part down. But if you struggle, it's probably because you're trying to do two things at the same time. And in math, that's a recipe for disaster early on, because we'll get it right half the time and we'll get it wrong half the time. And it's just when we get it consistently right. Okay, so far so good. Now do you want to see how to get the extra credit? You see there's a method to my madness. Everyone goes after the extra credit. If I put factoring on the test, you'd probably put it off because it's no fun. But if I make it extra credit, everybody gets, now it's sort of kind of fun, right? Because it's extra and I don't have to do it. So I'm doing it because I want some extra points, right? But it always works. So what we do for these factoring, where this part comes from, it comes directly from X-Intercepts. So what I do is then I kind of take my X-Intercepts. Watch this. I take this x equals negative 4, and my other one is not really nicely written, is x equals 3. So I take the X-Intercepts just as x values. And to get the factoring, what I'm going to do is I'm going to get these equations equal to 0. So if I've got x equals 4, how do I get that equal to 0? Add 4. Good. So I add 4, and I get the equation, or I get x plus 4 equals 0. What I just figured out, that's one of my factors. And this is how you use these X-Intercepts in MAT150. So this is the way I want you to do it, rather than the book will take you through. There's a whole section on just kind of look at them and play a game and factor them by figuring out, 3 times 4 is 12, but 2 times 6 is 12, and playing with numbers. Just find the X-Intercepts and it'll factor itself. So x equals 3, how do I get that equal to 0? Subtract the 3. So after a while you'll see you're right, it is just the opposite sign. So negative 4 became a plus 4, positive 3 became a negative 3. So once you start to see the patterns, it sort of makes it easier. Oops, what did I do? X minus 3 equals 0, so x minus 3 goes in here. And now if you FOIL this out, what do you think you're going to get? Except we don't get the negative. We actually get negative 12. So this is the thing. to make it work, there's also, and you'll run into this to 5. But if you've got this, I'll give it to you. But to get the negative in front of the x squared, and notice positive 4 times negative 3 is a negative 12. So we'll just stick a negative out here. Okay, just kind of a fix, like a negative 1. Actually, this is a good thing, because in 150 you're going to do this. So the X-Intercepts, they give you the factors, but they don't really tell you whether it opens up or it opens down. You have to look back and figure out, if it opens down, I need to put a negative there. If not, I'll tell you what, if you get the negative part, that's an extra point of extra credit. So the factoring itself is extra credit, but there's extra credit on top of the extra credit if you get the harder part of it. Does that make sense? I just give you a pair. So this little negative 1, again, you're going to see it in 150. If you don't remember it or don't really quite understand it, just forget about it. If you got x plus 4 and x minus 3, you'll get extra credit just from the X-Intercepts. Okay, but this is something you're going to learn in 150, and I just want to give you the basis so that when you see it the first time, oh, that's what Little Crow was doing. I didn't understand what he was talking about, but now it kind of makes sense. So sometimes that happens, and that's why I like tutoring, is because when I say it the second time, that makes me look really smart. And it was really the teacher that taught them. It just didn't make sense until they heard it the second or third time. So you always look, so that's, yeah, if you can do tutoring, it's a great time, because you don't even have to be a great tutor to look good. It's just you help people understand, and they'll give you the credit instead of the teacher that first taught it to them, because it's just, that's the way it is. I found it. When I teach it, you don't quite understand until you go to and get it explained a second or third time. And if it's me you're working with, then you think I was the one that explained it to you. But it's just all these concepts take 2 or 3 times of looking at to really make sense. So is that good so far? So there'll be, I don't know, 4 or 5 or 6 of these type of problems where I'll give you an equation. You'll have to do the ABC. You put it in, and you just give me basically all this information. There'll be a few that have extra credit for factoring at the end. Of course, the ones that are already factored go the other way. So, but I want you to see that factoring is not that big of a deal, and factoring really does come from the X-Intercepts. That's where it's all coming from. Okay. And as you see, more problems here, more problems, more problems. There is a solutions guide in Canvas, so go ahead and pull that up. Take a look at it. Sometimes if you look at it, if you're not quite sure what's going on, one of them might help you understand it. But they're all based on using atom quad. Okay? Sometimes there's students who haven't been in class, and I understand that, and they go through the book and they teach themselves it. If you don't use atom quad, you can use all the formulas, but that's a hard way to do it. Okay? The reason I want you to do it the easier way for the calculations is I want you to spend your mental time focusing on understanding what's going on with the quadratic, rather than focusing on the calculations that really don't teach you anything by plugging into that formula. And actually they kind of get in the way. They take your mental energy, and then you don't have time to understand. I want you to just have atom quad give you all the answers, but draw the pictures and figure out what each of those things are. Once you've got all that, then go ahead and go back and take a look at the formulas. I think it'll help build your mathematical abilities. Okay. But let's go ahead and go to these. This is the second type of problem. And again, I give you 4, maybe 5 or 6 of these. You're going to see this is actually easier, because it's really the same thing, but all I'm asking for now is really the X-Intercepts. And I even put it, find the X-Intercepts. Okay, but this is called solving a quadratic. Okay, and in the book they do show you a method where you graph the left side, graph the right side, find the intersections. What I'm going to do is teach you that basically if you get this equal to 0, you can use atom quad. Do we have to have it equal to 0 to use atom quad? Why? Yes, because atom quad tells you that at the very beginning, if you don't satisfy the if, you can't use atom quad. Atom quad only works if the quadratic equals 0. So remember that, because this is where I see people will, I if they get it wrong, what they've done is they've entered A, B, and C, but they forgot to get it equal to 0 first. Okay. Some of these are already equal to 0, so those are the easier ones. But so I'm up here, 2x squared minus 5x equals 6. How do I get that equal to 0? I subtract the 6. So it's really, if you want, you think I'm just moving the 6 over and it becomes negative, that's fine. I'm actually going to write it down. Okay, so these cancel. And really what I'm working with is 2x squared minus 5x minus 6. Now when I'm subtracting 6, remember I can only do it with like terms, so I can't take negative 5 minus 6 and get anything. I really have just moved that term to the other side. But now I can use atom quad by filling in A, B, and C. And the solution, what I've done is I've basically moved that quadratic down 6 spaces. You'll see this in 150 as well. And my solution is where does it cross the y-axis? What x values give me a y value of 0? That's an x-intercept. Okay. So what is the value for A? 2. The value for B? -5. And the value for C? So we grab our atom quad program, and again, however, if it's not running, get it started. If it's already been running and you just restart it, you won't have to do options again. I think I still got mine running. I go to 2, I put in -5, and I put in -6. Come to my menu. I'm going to go to the graph just to show you because this will be important. This will tell you whether there's actually even an answer or not. It's possible that some of these may not be solvable. And the reason we know they need to have x-intercepts. The graph will show me, because is it possible for this to not have an x-intercept? Yeah, if it doesn't cross the x-axis, then you'll understand what it's going to give you. I think there's one of these, and I'll try to figure out which one it is, and we'll do this. So now that I've seen the graph, I actually didn't draw a picture of it, but that's okay. I just go to view results. The x-intercepts are my answers. Okay. And in this case, it's not actually, since it asked me to solve, I don't write them as ordered pairs, I just write them as x equals each of these. So when x is negative 0.886, or when x is 3.386, when I plug those values in for x, the values are the y value is going to be 0. Okay, that's my solution. So notice how this was sort of like the other one, but all they're asking for is the x-intercepts. So whenever you see solve, and you'll see this again, solve just means get it equal to 0 and give it the x-intercepts. And that's one method. There's some other methods. You could graph both sides and find the intersections. We were doing that too. But since we have the power of atom quad here, get it equal to 0, plug it into atom quad, and the solutions are the x-intercepts. Because when you plug those values into the equation, it ends up being 0. Okay, so that's that. What I'm going to show you, I'm going to get out, and then we don't need any of this other stuff for these particular problems. So I'm going to exit. I want to show you, if I put this, like, I'm going to put in that negative 0.886. So I'm going to take 2, negative 0.886 squared, subtract 5 times negative 0.886 minus 6. So I plugged it into the quadratic. I hit 0. Oh, does that look like 0? It's a good thing it didn't. It doesn't look like 0, does it? But I'm going to show you that this is a calculator's way of saying 0. What is that number? It's -8. That e means it's an exponent on 10 to the -6. So the -6 is an exponent on 10. This is called scientific notation. And so what does scientific notation mean? What does that -6 mean? Good. it goes, so it means move the decimal over 6 places to the left. 1, 2, 3, 4, 5, 6. So this number is really 1, 2, 3, 4, 5. It's negative 0.000008. That's pretty close to 0, isn't it? We'll call it 0. So you'll see this sometimes when you're looking for 0, it gives you this kind of a number like this, and that's as long as it's a big enough negative, right? It's going to be 0. Does that make any sense? No. Okay. I'll just. Okay. So this goes back to 082, and that's why we teach. But the thing with math is you got to remember things from 3rd grade when you're doing, advanced stuff. I don't know if this was 3rd grade or 4th grade or 5th grade, but it was actually, I'm sure you learned something about scientific notation. Maybe it was junior high, but some of you probably learned it in grade school. It's in chemistry as well. So so sometimes this is where some people say don't take science and math at the same time. Actually, sometimes they help each other out. Okay. So, but the main thing is just that it's a very small number. It's just trying to be too overly accurate. It's close enough to 0. We'll call it 0. Okay. And it's probably because these are rounded. Had these not been rounded, it probably would have been exactly 0. Or when you get ones that are like integer values, when you plug it in, you'll probably get exactly 0. But sometimes your calculator gives you weird numbers like this, and you just have to interpret. That's really just 0. Okay. So each of these, and again, so 11. What's the first thing we have to do to get this to be able to be usable? Have to get it equal. So we add 12 to both sides, right? We won't do this whole one. Well, let's see, 3x squared plus 5x plus 12 equals 0. Now we can use Adam Quad, put in A, B, and C, and we're get the X-intercepts. I think 12 is 1. 12 might be 1 that actually doesn't have any X-intercepts. So I want to give it a try just so that you see what happens when there are actually no X-intercepts. And then I'll show you what I want you to write. Okay. So this one's already equal to 0, right? So we can tell our values for A, B, and C. What's the value for A? 1, the invisible 1 there. B, good, and C, 2. So we're going to come to X. What's that?
I think it crosses the X.
It does? Darn. I was hoping there was one that didn't. If there's not, I'll make one that doesn't. Because I think there's one on the test that doesn't. So we're going to look at the graph. Yes, it does. So, okay. It crosses, and so all we have to do is go to number 2 is view results, and there's our answers, right? The solutions are what x equals 3.414 and x equals negative 0.586, counting it to 3 decimal places. Okay. So see, when they ask you to solve, get it equal to 0, the answer comes directly from the X-intercepts. Okay. And again, try the other ones. It's probably that last one, but let me, oh, I know, I can do this. I'm going to show you one. You doing okay? Okay. So I usually find that people who aren't doing okay don't want to say anything, but please say something if you're not. I'm going to go to 6. I'm going to make one up right now. So I'm going to say A is 1, B is 4, and I'm going to make C like 12. And I'm going to show you this graph. And notice it does not cross the x-axis. Okay, so when you graph one and it doesn't cross the x-axis, will it have any solutions? No, because it doesn't have any x-intercepts. But what does Adam Quad tell you? You go to view results. it looks like it gives me this weird stuff where you have to look. It's way on this side. You see that eye? What is that eye? Imaginary numbers, yes. We're going to talk about them in a minute. But for us, we want just real solutions. So if they want real solutions, what we put here is D and E, that there are no solutions, okay? So had this one here been plus 12, so had you gotten a question that was x squared plus 4x plus 12 equals 0, and it said to solve, for your answer, you will just put D and E. Okay. Don't put these funky numbers. I guess it's better than nothing. And if you understand what they are, I guess that's okay, but I'll bet you the reason you're putting them is you don't understand what it is and you're not sure what's happening. Because I want you to see it did not cross the x-axis, so there will be no real solutions. They're only imaginary solutions. Okay. And where these imaginary solutions actually have value primarily is in things like electrical engineering. The smartphone, the chips, the way they've gotten these chips, these computer chips to be smaller and smaller and smaller and get more and more stuff on them, is they're actually using imaginary space on those chips somehow. Engineers are actually using imaginary numbers to get more information on a smaller and smaller chips. That's where it all comes from. So all this technology, you might think imaginary numbers are just made up, and they actually originally were, but there's actually a purpose. There's actually a physical, real use for imaginary numbers. It's amazing. So computer people, but again, it's a very limited use, but there is a use for it. Okay, and they really just came out of someone said, "Oh, square root of a negative number. Let's just make something up." And it's weird. It actually physically ends up working for something. You know. Okay. We're almost there. So, and again, what are we doing on Wednesday? More of the same. So work through this. You can look upon it as a work session. You could come or not come. It's up to you. I'll just be here for answering any questions. If you need people who haven't gotten Atom Quad yet, we could do that. But if you're okay and you're feeling confident, you're welcome to work at home. And just kind of. But that's basically because there's only two other type of problems. There's this one, which is a regression problem, and there's these ones which are calculating with imaginary numbers. And basically, I'll show you how to set up your calculator to do this, and this we've already done. Okay, regression. The one thing I want to point out, though, is this line right here is very important. This line says let t equal the number of years since 2000, t or x. So since the year is 2000, what's the value for the input going to be, my x or my t? How many years after 2000 is the year 2000?
0.
Good. 0. So the key part, since we're starting in 2000, basically we're going to take each of these years and subtract 2000 from it. So 2000 minus 2000 equals 0. 2001 minus 2000 equals 1. 2002 minus 2000 equals 2. And 2003 minus 2000 equals 3. And 2004 minus 2000 equals 4. So when you go to put these in your regression for your TI calculators, you're going to want list 1, list 2. You're going to want list 1 to be 0, 1, 2, 3, and 4. And believe me, I can tell the difference. If you put in 2000, 2001, 2002, you get an equation that matches this, but your t values are 2000 and your equation's actually different. Okay, and I'll know it. It's sort of it's a usable one, but it didn't follow this instruction. So if you do that one, I give you partial credit. but to get full credit, you have to use this renumbering, and then your equation will match my equation. And then yeah, this 6.28, 8.56, 13.01, 19.01, and 23.13. We're going to put that in. We're going to do quadratic regression. It gives us our quadratic equation, and we're done. Probably could do it in about 4 minutes. Do you want to go through it?
Sure.
Okay.
Results in the answer key.
Okay.
Because I followed exactly what you did, 0, 1 to 4, then I got this result.
Okay. Let's see what's going on here. Sometimes I got so many different versions of worksheets. Sometimes the answer key might have been for a slightly different version. I'm not sure. It might have been the same version, so we'll see. Oops. And here's the trick. When you want to get out of Atom Quad and you hit enter, it goes right back into Atom Quad. Just put some numbers and then hit 7 and then put like something else in so it remembers. So now when I hit enter, it remembers 9 instead of Atom Quad. When you get out of Atom Quad, if you hit enter again, it will start rounding Atom Quad because it's still in its memory. It was one of the first frustrating things. I couldn't figure out how to get out of Atom Quad.
Could you go over how to get out of there again?
Sure. So once you're in Atom Quad, you have to put numbers in sort of to get out. So go down to number 7. Hit enter. Now, if you're not careful, if you hit enter again like I did, it will start running the program again. So what I do is you just put anything in that isn't Atom Quad. So any number like 5, enter. Now the memory has 5 in it. Notice every time you hit enter, you see 5. But that's easier to deal with than Atom Quad starting to run again. Okay.
So are you out of it?
I am out of it. I'm completely out of it now. And it's not even in my back memory, so when I hit enter, it's not going to start running Atom Quad again. Okay. So that's one of the things. Okay. So I'm going to hit stat, because this is regression, right? Okay. What do I do first?
Edit.
Edit. And I've got numbers in here, so I'm going to clear and enter. L1, clear and enter. I've got my list over here, list 1 and list 2, so I just put these in. I put 0, enter, 1, enter, 2, enter, 3, enter, 4, enter. Each time I hit enter, it moves down. Arrow over and put in the Y values. 6.28, enter, 8.56, enter, 13.01.
That's 13.03.
Oh, maybe that's it. We got different versions.
You have 0, 1.
I have 13.03. Here it is. Okay. There we go. Okay, thank you. Yeah, that would have been 13.0, and then 19.01, 23.13. Yeah, that's the problem, is if you can take it directly, because I have this problem when I write things down, I tend to copy errors. I have a hand that just likes to do whatever. It likes to be creative, but in math, with numbers, it isn't always helpful. Okay, so I got all my numbers in. We look pretty good. Where do we go next? Back to stat. Oh, and then this calc. So there are different types of calc, right? So we got to be careful. So we hit stat and then over to calc. And then now what kind of a calculation do we want to do? Number 5, and I'm going to arrow down just to highlight its quadratic regression. So you've got to do the right regression. Okay. I hit enter. Now we get all these along the way. It's telling me I've got quadratic regression. We hit enter until it calculates. If you've got a TI-83, you might just hit enter directly. There's each model has a different thing. It gives me the sample at the top, so I know I'm dealing with quadratics because it's ax squared plus bx plus c. it then gives me the values for A, B, and C. And then what I want to do with those is I don't want to write them down separately. I want to write them, it doesn't tell me how many, let's go to 2 decimal places. So for A, I'm going to write 0.37 t squared plus 2.93 t plus 5.91. And that's my equation. Does that match what I have on the answer key?
That's what I have. Because if you click stat and edit, you'll see the same exact results. 0, 2, 3, 4.
L2, stat, calc,
5.
quadratic regression. This is gotta be something.
We get
Look
20.
again. 0, 1, 2, 3, 4. You just at least get it recorded. Look at them side by 0, 1, 2, 3, 4, 6. Oh, you got 6.82
Oh, A2.
instead of 2. Yeah, see, I had to really look closely. 6.28.
2, 8. Okay.
And sometimes it's those first ones. So you transpose, and I mean that's one of my favorite tricks to do is transpose numbers. Yeah, if you could, and those are hard to find. Yeah, it looked all right.
You gotta turn your paper upside down.
That yeah, and then I can read it. That's one trick I use because I look at it from different angles. Yes.
I don't know. I'm glad I ain't the only one with different numbers.
Okay, so let's go back to stat, edit. You got 6.28, 8.56. Oh, it's right here, number 3. You've got 0.01. So you did get the 19.
19.
Yep.
Okay.
So one bad number, even just a little off, like I had 0.01 instead of 0.03 for the 13. That would have probably caused us some problem. I mean, it would have been a little bit off, but the more off you are, yeah, if you had like 1 point, it'll come off. So just be careful. So that's the real key part of this is once you have it in, just methodically go over it. Again, the goal really isn't to try to trick, get yourself, but just take the time because this is the type of things you might be doing on a research project, and you're inputting data, and it's all the hard part we go through to get these equations and stuff, and that thing that seems like the easy thing of entry error, but that's sometimes the hardest part to catch.
I don't mind asking because I feel I was taught the only dumb question is the one that you don't ask.
Exactly.
Correct.
Yes.
Ask.
And those are like like RJ, what he had is he had 6.82, and I was seeing that my mind was looking at that. Yeah, you got the same number I got, and then when I put them down to look at them a little bit closer, I go, oh wait, there is one that one's transposed. So it's, yeah, and the 19, a quick first look, it all looked good because you're looking at the back sides, and then you had to really, So anyway, and that's why sometimes if you'll write down, but again, sometimes the more times, but that's all that one's about. Okay, so come up with the equation. We don't have you do anything more with it. But in like if those of you who are going into business, we have brief calc, which is the business calculus, and there's at least the way it used to be, the first chapter was about doing a lot of different regressions because you use regressions to take the data to turn it into equations, and then you use those, that's how you do your work after that. You do the calculus based on these equations that you come up with, but in the business one, it typically will start with data, because that's how it usually works. Okay. So far, so good. Got enough room left in the wandering mind to do one more thing. Okay. So the first thing is we need to teach our calculator something. You probably thought the calculator was smart, but it's not. In fact, it knows how to do a lot of things, but some things have been turned off. So what we're really doing is we're going to turn on a feature that has been set to be turned off. And what we're going to need to do, if you do second quit, you just get back to the main menu. So this is not inside of any program. What we're going to do is we're going to teach it how to get imaginary numbers. So we're going to teach it how to take the square root of a negative number. Yes?
I got a question. Like we're doing all this, and you're teaching us how to do it with the calculator and such, and how we progress with the calculator. How many do you think that this here course can be done without a calculator? Would everybody in this classroom be able to do it without a calculator?
Yeah, if we did it over 2 semesters, we could do it.
Oh, okay. I just want to know because I don't want to feel
Yeah. Yeah. We could teach without calculators, definitely take 2 semesters. And we lose half of it, including me. It's just so tedious. But the advanced stuff we're able to do with the calculators, that's really what moves us forward. We're actually doing, and we would have to sort of dumb it down without calculators. We'd have to get easier problems. And this allows us to do more real-world type stuff and to do some actually higher-level mathematics with these calculators. Okay. So what we're going to do is we're going to teach it. We're going to go to the mode button. Mode is a very important feature in the calculator. It sets all the things up. I've got mine on degree, so there's this radian degree. That's not really going to affect us. You'll see that when you get to trig. That's something you're going to want to do. But what we're looking at is there's this line down here that says real, a plus bi, and then there's this other thing over here. What we're going to do is we're going to move it over to the a plus bi. That's an imaginary. It's actually technically a complex number. The I part is the imaginary part with the real part. So we're doing what they call complex numbers, which includes a real and an imaginary part. So once we've done this, we are now set. Because now we can take the square root of negative 49. How did I get out of that? So if you're in the modes screen, just hit second mode, which is the quit, and it gets you back. There might be other ways to do it, but that's the most elegant way I found. Second quit kind of gets you out of a lot of stuff. Okay, and then what we're going to want to put in is the square root of negative 49. So this is what I have to, the square root button is, notice this x squared. Above it, it says there is a square root. So to get the square root, we have to go second x squared button. Oops, I hit the wrong one. Second x squared, so you get the next square root. And then I want to put in negative 49. Now remember, this is the negative key, that little one, not the subtract key. If you use the subtract key, you'll get a syntax error, which means it doesn't know what you're talking about. And we'll figure that one out. We'll put 49. Does anyone have an idea what this might be?
Positive 7?
7i. So yeah, so it is a positive, so it's not a negative number. It is a positive 7, but it's got the I. It's an imaginary. So it's just like taking the square root, but because where this comes from is there is no number that you can multiply by itself and get a negative. Because a negative times a negative is positive.
So I just put the bracket on it?
Just put the other bracket, yeah. And actually, you're probably okay if you don't, but it's probably better to do that.
Okay.
Yeah, so, I should have had, well. Yeah, some of you, what you get is you just get a line, and then it does this. It's sort of, and then it gives you a parentheses. And so when you do negative 49, you close it with a parentheses, and you're fine. Okay. We'll also be doing things with square root functions as our last in, I guess, 9 and 10, one of those lessons, and we'll tell you more about those. But that's all there needs to do. So I can take square roots of negative numbers all day long, and it's just gonna, so square root of 121 is 11, so the answer is 11i. And then watch what happens. So these are called complex numbers. All right, 7 plus 4i, 2 minus 3i. And again, I could show you how to do these, which I will, but I can also show you all you have to do is enter them in your calculator. 7 plus 4, but now here's the question. Where's the I on my calculator? Take a look at yours. At the bottom, good, you found it. It took me a long time. Actually, a student had to tell me. It's right above the decimal button. So notice above the decimal button is the little I. It's in blue, so you have to hit second I. So if you know that, close the parentheses, and then 2 minus, now that is the subtract key, sorry, 2 subtract 3i. So you're just going to enter it in the calculator. You're going to hit enter. It's going to give you your answer. (26 minus 13i). You okay with those last ones? Would you like to see how they're done by hand? Okay. So, and this will be, again, I wanted to show you what you needed to know. Now you can forget all this if you need to. But I also want to show you where it comes from, so I'll just do it here. What is the imaginary number? What is I? Nobody knows. But they know that if you take I and you square it, you get -1. Why? Because that's what it was invented for. It was just defined. I squared is -1. And it's the only number that does that, because if you take -1 times -1, you get +1. If you take +1 times +1, you get +1. So the only way you can get this is to make something up, and that's what they did. So they don't really know what I itself is, but they know when you square it, you get -1, because that's what they invented it to do. Okay? So what they did, what the calculator did with this, so I'll just show you, is it really just foiled it out. So I'm going to show you how to get the 26 minus 13i by hand. Not that you need to, but just in case down the road, right? So we just FOIL. 7 times 2. 14. Still in a place you can see. 7 times -3i. Would you agree that that'll be -21? Because 7 times 3 is 21. I. And just treat the I like as a variable. 4i times 2. Would that be plus 8i? Yes. And then 4i times -3i. 4 times -3 is -12. I times I is I squared. Okay. So we combine like terms. -21 plus 8. So we're going to subtract. So that should give us, what, 13? And it's going to be -13i. 14's there. And then what is -12i? Well, remember, what is I squared? It's -1. So this is actually -12 times -1, which is a plus 12. So what's 14 plus 12? 26 minus 13i. Or just let the calculator tell you. Okay. But I just wanted to show you it's not rocket science how they came up with it. It's kind of tedious. But I want you to not to worry about it. I want you to use the calculators and then focus on what it all means, right? So you're just going to be fine with this. If you have to use imaginary numbers, you're going to be fine. But where would you use it? Anyone remember where I said you might use imaginary numbers? Anyone going to be a chip scientist? Engineer, and electrical engineers that are dealing with microchips or something. it's got a very limited application, so don't worry too much, but that's where it all comes from. It'll be fine. And that's the test. A few of these, it's nothing more than this. One of these, I don't know, maybe 4 to 6 of these kind, and then the 4 to 6 of the other kind. Just work them forwards, backwards, sideways.
I just have a quick question.
Sure.
Okay, so the one that you have here.
Uh-huh.
So I did second left there, negative 49, enter, correct? And I get that.
Okay, so you must not have changed your mode.
Okay, so that's what, so could you tell me how to do that?
Hit enter to
Okay.
go to your mode. Come down, yeah, you're still in real mode. Go over to
And hit
and
enter.
hit enter.
Okay, I didn't hit enter.
And your thanks for reminding me, every time you use Atom Plot, it will switch it back.
Okay,
So once you use Atom Plot, you have to
it,
come
you
back.
gotta
to
go
it.
back.
Yeah.
So how did, and then it's done.
Yeah, and just leave it in there.
So how do I get off of the screen?
Oh, second, quick.
Okay. Okay, so then it should work. Okay, there we go. Thank you.
You're welcome.
I'm gonna take one of these extra ones.
Perfect, thank you. And like I said, I'll film anything we do and then upload it. But it's going to be just those. So before then, if you can get the rest of them worked out, it's really comfortable. Then just say, yeah, I don't even have to worry about this issue. Yeah, we'll get you there.
Quick question.
Yes.
For the test, say, for example, I got these flipped, say, instead of negative.
Yeah.